Should be working right now. What's up, guys? This is Aiden right now. I'm in Professor Susan Vanderplas's data wrangling class for the spring 24 semester. And today we're gonna be conducting some. Oh, don't want to see that. We're gonna be conducting some data analysis, and yeah. So this is gonna be my topic. This is the data set that I chose. It's gonna be about the NCAA Men's March Madness for this year. And yeah, I kind of found this data set uh, from TidyTuesday GitHub. Alright, I think I should cut the bullshit. Oh, in case I swear, I guarantee you, Dr. Vanderplas is okay with that. So I'll try not to swear too much because she's currently playing a drinking game right now. So every time I swear, she will take a shot or a sip or something like that. Alright. Um, so I just want to go through some of the. I just want to go through a bit about the data set right now. It's basically going to be about the statistics for all the teams um that played in the tournament from 2008 all the way till 2024, and except for 2021 because COVID obviously hit that year. But there's gonna be two data sets, and this is the first one. It's about the team results, which tells you like everything you need to know about the team for the last like 18 years. Okay. And yeah, I think it's 18 years. Yeah. And then there's going to be the second data set here that tells you about the percent of people who pick each team to win each round of the tournament. So we have like round 64, round 32, Sweet 16, Elite 8, and Final 4, and the finals. So this is gonna come as percentages. So we might have to. I already found the population for like the number of people who pick these teams, so we're probably just gonna find like the percent of people, and then all right. I don't talk too much about that. This is just like a rough intro of like the data, and let's go to R real quick. Wait, where's my R? Oh, there we go. Okay, so I already created like a pseudocode roughly that I'm gonna follow. Hopefully we can complete it in 45 minutes, but um let me just go to the file that I'm going to use to code. All right. So I'm just going to code some of the information here. My name is Kai Shen Chung. You guys can address me as Aiden. This is my NUID. STAT251 final screencast. Okay. All right. So I'm just going to run through with you guys what we're going to do today. So, Professor did mention that we have to use at least 4 skills learned from class and to investigate 3 different questions. Well, for me, I already spoke to her about this, and I'm gonna do this in a bit of a different approach. So, I'm obviously still gonna use 4 or more skills that we learned in class today. Some of them include joining tables, data cleaning, data visualizing, using converting strings, and using functions. All right, so these are some of the skills that I will be using apart and including another skill which we haven't learned in class, but I learned in another class, which is using linear regression models. I'm not going to emphasize too much on that because this is a data wrangling assignment, but that will be part of my method to investigate some of the questions that I wanted to. All right, so before I start those questions, I'm just gonna be cleaning some data, joining some tables, cleaning, and then converting some of the strings into necessary data types that we need. And then after those 4 steps, I will be solving the questions. So we have instead of doing 3 questions, I will have 2 questions, but the second one is more like a bonus question because like I don't really need that question anymore because the first question kind of solves everything we need here, right? Which is, which factors have the highest influence on the public to pick a specific team to have a deep championship run. So as we can see from here, there's a lot of like predictive variables that we can use, a lot of factors to consider when teams which can influence like the public to pick a team to go like far. All right, so what I'm trying to focus on in this project is to see like which factors have like the greatest influence, like when the public decides to choose like team A or team B to go for a deep run, which factors are going to look into the most. Okay, so that's what I'm going to focus on. It's not going to be easy doing that. I've created like the pseudocode for it. It's kind of difficult, so I'm hoping to finish all of this within 45 minutes, so but we'll see. All right, and throughout, although I'm only investigating one question, from cleaning the data, from preparing the data to solving that first question, I've already gone through like five. I will use like all five skills, so I think that's like safe enough. And I think like we're gonna do a lot of data analysis at the end of that first question to see like what we have. All right, so without further ado, I'm gonna start coding right now. The first obvious thing to do is to read the CSV. So actually, no, I think I'm going to download like the necessary libraries first. Okay, give me a second here. So all right. Okay, so these are some of the libraries that we will be using. I'm gonna like write them all here right now, and then I'm gonna explain to you briefly how we're gonna use them. All right. Yeah. Hope you guys' day is going well right now. It's currently 12 p.m. I actually currently have a class with Dr. Vanderplas right now, but like I wanted to do this before her class, but I just couldn't wake up, so sorry, Professor. All right. These are some of the libraries that we will be using. Depler obviously is for data cleaning. String R will be used for converting, because like as we can see, with data analysis, you want to have most of them in integers, and some of them are going to be characters. Like these are like the percent of people who pick each team to go to each round. They're going to be in characters, so it's going to be a bit hard to do to clean the data, to filter the data if they're characters. So we're going to keep them as, we're going to have to convert them to integers. That's one example. ggplot2 is because we're going to use that to visualize some of the data, to create like graphs and all. Per is going to be used for mapping, which comes on the function. This is something that we learned last week, and I felt like it was quite useful when I did the testing, so we're going to be experimenting that. And then this is something that we never just learned in class, which is library NLME. I don't know how you pronounce that, but this is basically going to help us create like the linear regression models, and I'll be speaking more about that in case you're wondering what the heck that is. Well, I'm surprised I haven't swore a lot so far, so this is like good, because I usually swear like 24/7. All right. Okay. So first thing we're gonna do is read the data sets. We're gonna read two of them. I have read them before. There we go. Okay, I'm just gonna copy it here because I don't want to waste too much of you guys' times. So reading CSV files. All right. So I'm just gonna run this first. Boom. I don't know what that means, but I'm pretty sure I have all five libraries ran now. And then I'm gonna read these two CSV files. So get rid of this, rid of that. All right, and as we can see, this is the first column. And this is the first data, and then this is the second data set. All right. Now, one thing to keep in mind here is that for the first data set, the public picks one. This is for like the year 2024, as we can see over here. All right. So in case you don't know much about about March Madness, it's usually 64 teams battling for first place. It's kind of like an elimination game, and then yeah, there's 6 rounds to progress through. You got to win all of them, and then you're crown champion. So there are 64 teams here for the public picks data set, and then for the team results one, as I mentioned earlier, the data was collected from 2008 all the way till now. So there's going to be 245 teams right here. We don't want all 245. We only want the 64. So the first thing that I'm gonna do is to join the tables. All right. So I'm gonna be writing some comments later, because if I write them right now, I don't think I can complete it in time. So I'm just gonna update it a bit after the screencast, so like Professor Dr. Vanderplas has like an easier time what do you call it, reading the code. All right, but for time's sake right now, I'm not gonna do that. So first step we're gonna do is join the tables. Okay, so we're gonna be using Depler's left join. In this case, it's gonna be way easier. So I'm just gonna use joint df, and then we are going to be using left join, and then the left one will be public picks, because we want all the elements from public picks to be in the current the new data set. That's what we're gonna do. All right, so public picks, and then the right data frame would be team results. All right, and then the key that we're going to be using, that they both share in common, is team. As you can see here, it says team, and then it says team here. So we're going to be using that. Make sure they're all in caps. All right, and let's run this. Boom. And join DF. Let's see how it looks. All right, perfect. Everything is here. I don't know how I like this right now. That's weird. I did not expect this. Oh, okay, wait, never mind. Okay, I get it now. As you can see, the public picks data was all on the left side, which explains left join. All the percentages are here, and then everything from team results is from team ID onwards, okay? And as we can see, okay, so if we're looking back at like the original data sets, we can see that they share some of the names, like round 64, round 32, sweet 16, E8, F4, F2. All these are and then the public picks one also has like the same column names. So I just want to go back to the variable names and then like explain to you guys. So in the team results CSV, it's those names talk about the amount of times each team has made to each round, okay? But in the public picks data set, those variables explain the percent of people who pick those teams to win that round in 2024. So very different. They are named the same, but as we can see in the joint data frame, they are labeled differently right now, in the sense that the percentages are now called round64.x, and then the amount of times that each team has played in round 64 is called round64.y. So originally my plan was to rename them, because I thought that they would share the same name, but I guess not now. So I think I'm gonna skip that step to save time, because I realize I'm currently like 15 minutes in. So let's just see where it goes. All right. The next step is to do a bit of data cleaning by removing any unnecessary variables. I think I spelled unnecessary wrong. Slash columns. How do you spell this? Oh wait, I see. There we go. Okay. Okay. Well, I'm kind of out of breath right now, but okay. So we're gonna be using Depler as well. We're gonna select, and then we're just gonna like minus like Is that, sorry, I'm mumbling right now. Okay. So I'm kind of using like ChatGPT as well. Professor did say we can use any form of like browsing to solve our questions. I use ChatGPT. Not all of it, definitely, but like it's just quicker to get the results that we want. All right. So just to remove some useless ones, I'm just gonna use the same just gonna use the same variable. And then we're going to be selecting, so we're going to be, the way we do is, how we're going to remove them is, we're going to be, let me just load this right here. Wait, I don't know how you do this. Oh, there we go. Okay. Yeah, not team results. Sorry, I'm going to use join df. All right, now we can see all the variables right here. Some things that we don't need is probably, for example, the team ID for both of them is going to be very different. Team ID in here goes chronologically from 1, 2, 3, 4, 5, 6. For the public pick, it's going to start from 1 grand. So I think we're going to use the public picks 1 because these are like the 64 teams that we want. So I'm just going to remove, what was it called? Team results. I'm going to be removing team ID. So minus team ID, and then I'm also going to be minusing what don't we want. I think the year is kind of insignificant in this case, so we're just going to be minusing the year. These are like the two that I had in mind. So let's run this, join df. Let's take a look right now, and perfect. The year isn't here and team ID is not here, so we need to have one primary key, which is team number. All right, perfect. But let's try to speed it up right now. What's the next move? We're going to, okay, my third step initially was to rename like the R64 and R64s here, like because they have the same names, but I think I'm gonna skip that step for time's sake because they're already different. So yeah, if we have time, I'll just change it for fun later. I don't think it'll matter as much, but we'll see. And then now step 4 will be working, we're going to be working with the strings because as mentioned just now, some of these info are in characters. We don't want that. And yeah, okay, so let's see. How are we going to do this? All right, looking at these are some percentages. Yeah, we don't want percentages, we want them in numbers. So first thing I'm gonna do is probably remove the percent. I'm gonna treat it as a string. I'm gonna remove the percent and I'm gonna convert. So it's like, for example, this is 7.16%. I'm gonna remove the percent. It's gonna look like 7.16, and then from 7.16, I'm gonna convert it to a integer. So I haven't really figured out the code how to do that yet. So I'm just gonna do it now. Given data set filled with percentage characters, how do I remove the percentage and convert the element to an integer? All right. I'm not gonna lie, I was kind of stressed before doing this, but it's actually kind of fun. So, but I just hope I get like a good grade out of this because I actually like did a lot of preparation. Like, sorry, just come back to the pseudocode, like quite a lot. So, yeah, I hope you like it, Professor. All right. So as we can see, these are the percentages. As integer G sub. I don't know what this library uses. I don't think it uses any. Alright, then we're going to use this example because your percentages are in a data frame. So we're going to put as integer, and then we're going to G sub the percent with nothing for this data frame. Okay, so I'm just gonna copy this example, for example. Alright, let me just see how to do this for multiple columns in the same data. I'm pretty sure we can use map for this. I'm not too sure how to use map because I'm not sure how to use map because we just learned it last week, so I'm still kind of confused. All right. I don't want to use a for loop. Let's see. There we go. That for hopefully. Alright, so mutate across, so I'm assuming across allows you to do multiple variables, and then we're gonna give the list of variables. So instead of subbing in like a vector of the given variables, I'm just gonna store it in an object first. I'm gonna sub it in. Perfect. This is exactly exactly what we want. Okay. Let's try this. This is me using mutate from Declar, so another data cleaning method that we've learned in the past. Alright, so wait, I wanted to use string art for this assignment. Use string art for it's actually wasting a lot of time. Actually, I should have done the preparation earlier. I didn't think it would take so much time. Hopefully we don't go too overboard. I think we're about like 20 minutes in. Not terrible. We're almost, this is the last step before we work on the first question. So I think we're on time, I think. Okay. I think this dot is like a placeholder. I'm not sure what FNS is. I'm still going to use it anyways because I need to use string replace. But let's use this instead, alright? Because I know that we're going to be doing it as for each of these variables. We're going to be replacing the percent with nothing. So that will just, so we're going to be using this one. I'm just going to copy this code right now and alter it. And so converting string percentages to integers. All right, this is how we're gonna do it. Okay. All right. So first of all, I don't want to be using a vector of this because it's gonna be quite a lot. So, there we go. Okay. So let's just look at join df right now. I'm just gonna call them percentage var I'm just gonna percent var goes to C, and then gonna be r64.x. Wait, do I have to? No, I don't have to put it in quotations. All right, perfect. Saves us even more time. R64 r32.x s6 sweet 16.x. That's what it's called, by the way. E8 is elite 8.x. F4.x, final 4, and then we have finals. That will be it for the percent characters here, and then there'll be other characters here that I want to convert. at the bottom two is F4% and Chan%. I'm just going to do those as well because we might be needing those later for analysis. F4%, it's going to be in all caps. Chan%. Yeah, okay, so these are some of them. So I'm just going to use the same data frame, join df, and then join df again. Oh, put a T right there. Across calls. We're going to replace this string, this vector with %var, which is an object that we've stored the what was it called? The variables that we need as integer str replace .x % with nothing. Okay, all of them include a %. So let's run this. Boom. How is it not, bro? What? Okay, I probably need to use a % for this. Probably need to put them in quotation marks. Oh my god, this is gonna take a while. Yeah, I'm probably gonna go over 45 minutes. So, Professor, I hope you're okay with that. Okay. Boom. Okay, they're saying across is not the right way. We should use all off. Hopefully this works. Bang. Oh my god, I was gonna celebrate. What's going on here? Alright, so they told me to use all off, but then now they're saying all off is wrong. So wait, join df, does it work right now? Oh, it does. But wait, no. Okay, I'm gonna change it to a different name because I want to see what's like the difference. Just calling it join df1. Okay, so this is like the old join df. 7.16. Okay, so it kind of ignores like the float value behind the like 0.16. For example, they're gonna ignore the 0.16. Oh, because I put it as integer. We don't want integer. We want a float. Okay, that's my bad. How do I get float? Wait, it's lagging. Oh, float instead. Okay, this is very interesting. Okay, that makes sense though. Okay, I think we're just. Wait, is it just as numeric? Oh, as numeric. Okay, gotcha. Yeah, cause just now when we changed it, it got like we got 7, 2, 0, 0, 0. You know, so that was like kind of weird. Let's go back to this. Gonna change to as numeric. All right. Boom. Join df1. Perfect. There we go. All right. Sweet. All right. Okay, we're kind of done for now. I think I'm like 27 minutes in. I gotta speed it up. Okay, so we're gonna be working on the first question now, which is which factors have the highest influence on the public to pick a specific team to have a deep championship run? So Damn, this is like so little line of code. It's bad. Okay. Let me just look through my notes to see what I have to do first. Okay. To analyze this, originally I was going to, for example, look at like all the percentages to see like I was gonna like put them in descending order for all rounds, but I feel like to see like like for the public which teams would they rather pick um to win each round, like which teams. But I think that that's not really ideal for my question to analyze all of them, so I'm just gonna do the final one. All right. um so how are we gonna do this? Oh, we're gonna use arrange, I think. Not sure how to use that. I'm just gonna search it here. How to arrange all values in descending order, because we're going from highest to lowest from a data frame. All right, so while come on, run. Okay, well that's running. I'm just gonna set up some of the. I'm just gonna set up some of it. Okay. Descend df. I'm just gonna call it that. I'm gonna use join df1. So I think we be using arrange. Hopefully, oh, it's still running. Alright, ChatGPT is kind of failing me right now. Might have to switch it up and. Alright, let me just refresh this if this doesn't work. I have to go with plan B. Okay, I'm gonna use sort values instead, not arrange, my bad. Okay. Okay. Oh, I really want to use that blue for this though. Let's see. Oh, not what we want. Oh, I didn't even state in R. Yeah, there we go. Okay, because I was like sort values. That sounded kind of familiar, but for like Python. Okay. Is this even running right now? No, my ChatGPT's dead. Alright, it's okay. We shouldn't rely on that. Oh, there we go. Yeah, it's dead. Okay, never mind. Not the most reliable. Okay, tidyverse, arrange sepal width. So sepal length is gonna be in descending. Alright. This is how we're gonna do it. So it's we're gonna use arrange. It's in descending, and we are going to be analyzing what? The finals. Okay. Perfect. Oh, what did I press? Okay. Boom. Boom. Descend df. There we go. Let's see what we have here. Okay. It's in descending right now. I do not want to look at all of them, so I'm just going to use hit to see like the top 5 values. All right. Boom, perfect. This is exactly what we want. Okay, the first 6 values. So as we can see, now we can do a bit of data analysis finally. So after cleaning the data, this is what we got. So we're looking at the final. We rank them. We arrange them based on descending order for the final value. So let's look at this column right here. 34.92 descended to 12.1, 10.22, 9.27, 4.78, 4.06. Okay. Um, just want to look at other values as well, like around 64, around 32. These are all like the percentages of people to pick those teams to advance those to win those rounds. So as we can see, this may be arranged in descending order, but it seems like the rest of them are as well. That's something we can tell, okay? So 50.27, 29, 21, 16, 10.93, 10.05, 66, 45, 44, 42, 30, 22, 80, 71, 66, 63, 59, 52, 93, 88, 86, 85, 84, 81, 98, 97.5, 97.1, 97.01, 95.5, and 95.2. As we can see, they are all following a pattern down. So at least for the hit. So that's something we can make a note of. I'll definitely just write something here to mention that. The percentage of people picking a specific team to advance each round follows a similar pattern for all rounds. Okay, I'm just gonna leave that note there. But yeah, that's something interesting that I will leave more remarks off. Okay, so now that we have it like ranked like this, what I'm gonna be doing is all right, this is where I'm gonna use my linear regression model. Okay, and I'm not gonna use too much of that, but I will be using functions and graphing in this part. Okay, so that's like 2 skills right there. So I already prepared the code for that because I knew that was gonna be very heavy, which it is. So let's just see what I have. Okay, but before that, I realized that it's not ideal to be using percentages for linear regression models, so we got to convert it to a value. All right, so we're gonna converting all the finals to. I might add another column. All right, yeah. I'm just gonna call it finals population. Okay. So what we're going to do now is we're going to multiply the finals percentage, like 34.92, 12.1, 10.22, all of those into a value, okay? We're going to multiply the percentage to the population, okay? That pick those teams to win. So I did a bit of research. I don't know if Professor requires me to leave a link. I'm just going to leave it at the end. It says that 22 million people voted for contributed to these picks. All right, so I'm gonna write population equals to 22 million, and then what we're going to do is we're going to add another column. I'm not too sure how to use Daplo for this. I don't really remember, so I don't think it's mutate. Mutate will be changing final, so I'm just gonna add another column. So the latest one is descend df. I'm just gonna name it finals Paul pop. Okay. It's going to be SNDF finals. So it's currently in 34.92% right now. So I have to divide that by 100, and then I'm gonna multiply that by population. All right, let's run this code and see what we get. No errors, perfect. All right. Well, I'm kind of tired right now. Okay. Finance population. Yep. 76. Let's just see right here. Let's run this back to. Yeah, we have a new value right now. All of these. So as we can see, 7.6824 million people voted for Connecticut to win the finals. All right, that's something that we want to use. All right, so okay, right now we will be using linear regression. Okay. All right, so okay, we're gonna be conducting each linear regression model for each variable. Um, the response variable that we're gonna be using is finals population, so that's like the one that we're gonna be observing. And then for the independent variables, which we're only gonna be using one, we're gonna be using quite a few of them. So, for example, I'm probably gonna use PAKE, PAKE rank, PSE, PSE rank, games, WL, win percent. Okay, we're gonna be using all of that. But well, maybe not all of them because we're running out of time and I don't want to do too much data analysis. But we're gonna speed it up by using map for this. Okay, so by using one function, we're gonna be performing a linear regression model for each variable. Yeah, for each variable. Okay, with only like one function. So that's what we're gonna do. I have the code written down, so hopefully this speeds up the process. Let's do it. I didn't expect this to be so tiring. Okay, let's go. I need tidyverse for this. I don't think I downloaded that. Probably. Okay, yeah, I missed one. Tidyverse. Boom. Ran tidyverse. Perfect. Now, I already have the data frame. I need the variables to regress, and I'm gonna store them in a vector again. So let's see what we want to use. PAK rank, I think they're the same. I'm not gonna use rank because, yeah, I'm not gonna use rank. So I'm gonna use PAKE. PAKE, if you're not familiar with it, stands for performance against computer expectations. I don't know how they computed that. It's currently in a double because like, it's in a float form, but I have checked like the descending and ascending, and it does work. For example, you see, PAKE. If I go from like highest, it's like 12.1. It works, you know. If I go from ascending order, wait, sorry, it's lagging a bit right now. Alright, so 5.5, next 1.5, 4.4, 4.4, 4.2 does work. So we're not going to be converting that, okay? Alright, so PKE. What else we're going to be using? PSE. I'm not too sure what these are, but let's just see whether they're effective or not, alright? And the goal with the linear regression model is to see is we're going to build a linear model with these variables, and then we're going to see how accurate we can use them to predict, to use these variables to predict the finals value, the number of people to predict each team to advance to the finals, okay? Yeah, I'm not very good at explaining, I'm sorry about that, but you'll see. After we graph everything, you'll see. When I don't think I'm gonna do loss actually. I'm gonna do win percent though. We're also gonna use R64. No, I'm not gonna use all of those. Probably gonna use the final two teams, the amount of times each team has arrived to the national championship, the champions, and top two. Top two is top two seed, so that will be interesting. So F2 champ top two. Oh, I really want to do F4% and champ percent, but they are in percentages. I don't think that's gonna really fit the linear regression model that well. I'm probably not gonna do that. I don't even know if like converting it to like, because they're gonna be in millions, and then these values are like the PAKE, PASE, they're all in like less than 100. So I don't know if that's really gonna be useful. Maybe I'll just not use the percent. We'll see. I'm kind of like blabbering right now, but it's because I'm also kind of confused. But all right. So I'm just gonna code it first and like explain it bit by bit. Map. We're gonna be mapping them to according to variables to regress. So we're gonna be using that vector that we just created. And okay, so it's going to be LM, which is creating the linear regression model. Reformulate. So we're going to be using the target value. We're not going to be using target. Target value is basically the response variable. We're not going to be using that. We're going to be using finals population. I really hope this works. Response goes to the dot. Okay, and then data will come from this, and yeah, which is the latest one that we have. Okay. So that will create like the models for each of these variables. That's what this code does, and that's the beauty of map. It allows you to do everything within one function. You don't have to create a function. It's just yeah, it's really like a built-in function, which is kind of nice. All right, now we're going to use map again because as you create each model, let me just try and run this code real quick. See what models have. Yeah, see, it's going to give you all this funky stuff. Yeah, not really gonna share what. This is definitely what we want. I just don't think I can explain it right now. So it's okay. Basically, I had 8 variables earlier, and they kind of created a model for each of those 8 variables. So that worked at least. Now, but because those like the model is like so complicated and like we don't really get information here, like we gotta go like dive in deep to see what we want. I'm gonna map them to the things that we want, which is a linear regression model gives you a lot of information, but what we really want to see is the p-value and the r-squared value. So that's what I'm gonna be doing right now. Gonna be mapping to models. And I want a list of like the values, so please give me the p-value, which is summary is from Doppler, I believe, and then coefficients. This is basically mapping to the p-value from the model. Don't want to explain too much of the syntax because I'm not too sure how it works anyways, but I mean, it makes sense at the end. I know how to map it, I just don't know like coefficient, comma 4, like I think that's where the p-value is located. R squared. Yeah, I think this will do. Boom. I got results. Gives me a list. Perfect. Okay, so as we can see here, p-value is not really coming out. Okay, this is not good. This is not looking too good right now. It's okay. Wait, what's wrong with the code? Okay, ChatGPT, I actually need you to help me on this because you were the one that found me that code. I'm just gonna close it and open a new ChatGPT window. Currently going overboard 7 minutes right now. It's I'm going, yeah, it's like 47 minutes right now. Hopefully we can finish this soon. Oh, I spelled coefficients wrong, that's why. Okay, let's see, team results. There we go, now we got p-values. So that's basically mapping. Alright, let me just try and explain what I just found here, okay? Because you guys are probably puzzled as to what the heck I'm doing. So each linear regression model, this function right here creates a model for each of these variables, okay? These variables will act as the independent variable, which is the x value, and then the y value will be the response variable, okay? So we're gonna see um, how these variables fit into a linear regression model to predict the response variable. Okay, I think I worded that right. Okay, so that's what this line of code does, and they created eight models for me. Now I'm using this code right here to get the p-value and r-square value out of those models. Okay, so I should be getting eight p-values and eight r-square values. Okay, now I'm trying to put it in like a string or like a data frame or something. No, I don't want it in a list. How to put all this information in a data frame. I'm so sorry for going overboard, guys. This is actually not as easy as you may think. I have to finish this because the last task for me is to create a plot, and I need to do that. So what? Okay, yeah, I'm just gonna use this code. Basically, instead of like mapping it and putting it in like this form, this list form. Wait, actually, what happens if I just call results? Oh, I really want that as well. I want the results df. Okay, so map df models table. I wonder if this will work. Oh, it does work. Sorry, I'm kind of confused right now. Okay, so what I just did to search is basically, as you can see from this data frame, like they're giving me two p-values. The first one is from the intercept, and the second one is like the one that we really want. So I don't really want the first intercept value because that's kind of useless. So let's just see. All right, p-value response var. Okay, I'm just gonna copy this code. I really don't know if I'm doing a good job explaining this. This is actually very difficult, but I'm trying my best, guys. So bear with me. ID Okay. I'm gonna add this. What is going on right now? Oh, I'm so lost, guys. Okay. Okay, I think this is exactly what we want right now. Okay. Oh, fucking perfect. Okay. Not the exact results that we want, but I'll take it honestly. Basically, okay, there is some interesting things going on here right now. All right. Um. Hold on. Let me just try one more thing, and then we'll be explaining. I promise you guys. Okay. I'm trying my very best right now. Okay, not the tidiest, but like, I guess this will do. Okay, guys, I cracked it. I'm just gonna be explaining a bit, and then I will be creating the graph, and then I think we'll call it done. Okay. Wow, this is stressful. Oh my god. Okay, not bad. Damn it. Okay. Okay. All right, guys. So basically, I created a regression. I think I already explained that. So, this code right here basically creates a data frame for each row would be like the linear regression model that I created, but instead of putting all the information from the linear regression models, I only got two of them, which is the most significant ones. One is the p-value for the response variable, and one is the r-square value. Okay, so the p-value here explains how significant this variable is, how statistically significant this variable is to the response variable, and the response variable right here right now is the what do you call that, the finals population, which is the number of people who pick each team uh to win it all. Okay, yeah. Okay, I'm just gonna say it one more time because you probably didn't understand me. So the p-value explains how statistically significant the p-value explains how statistically significant this independent variable is to relate to the amount of people who voted each team to win the championship. All right, so the smaller the p-value, the better. And statistically, if it's below 0.05, it is considered significant. So as we can see from here, the only one that isn't below 0.05 is the last two, which is the top two seed, which definitely makes sense because as we can see from the first seven variables that we analyze, all these are like let me just go back real quick. Yeah, all these are like information from the tournaments, except for PAK and PAK and PASE. Okay, performance against competition expectations and state expectations. These two variables have nothing to do with the tournament. But apart from that, everything else, games, which is the number of games played in the tournament, number of wins you got in the tournament, the win percent in the tournament, number of times you appeared in the final two, number of times you win the championship. All these are significant. All right, and as we can see, the most significant one is champion, which means the amount of times that each team has gone to the championship. All right, and the lower the p-value, that means it's more significant. So what I'm trying to say here is that this is the most statistically significant variable when people look into when choosing which team goes to the finals. Okay. Oh, I think I worded that very badly. Okay, but what I'm trying to say is this. Okay, this is a success. Honestly, I didn't think it would be a success. Like, and that's p-value. Okay, which is how significant it is. R-square value describes the amount of variance. Okay, the higher the amount of variance, the better. So, basically, it's like, each predicted variable, for example, win percent, can justify 11.8% of variance in the number of picks for a team to win it all. Okay, so the higher the variance, the better, and as expected, champion has the highest variance, which is 47%. That means they can explain 47% of them. Okay, I think these are in integers. I'm gonna fix it a bit. I'm gonna first of all, what I'm gonna do is I'm gonna arrange this based on the p-value because we're gonna be rating from the highest significance to the least. That's what we want to do. And then I'm going to change the r-square value to become a percent. Okay. I don't know if I want to do it now, honestly. I'll do it at the end of the video. But yeah, I'll do it at the end of the video. So you can like look at that if you want. Because that's like not really necessary for this. I mean, I'm going to do it for my own analysis and to make the data neater, but that's not very important right now. What's more important is creating the graphs. Okay, so I hope I explained that well enough. Yeah. Oh my god, I'm just so tired. Okay, I'm just gonna create a graph right now. I'm too tired for this. Okay, visualizing data. Okay, this is the last assignment, guys. Thank you for bearing with me until the end. Professor, I don't know how many of these have you viewed so far. I'm assuming most of the people have also gone overboard in time. If not, then I'm probably just a dumbass, but I'm trying my best. Visualizing data. I also have the code for this. Thank God I wrote the code. Okay. I swear to God, if none of this is like recorded, if none of my audio is recorded, I'm gonna be so fucking pissed. Okay, because I did test it before. I'm assuming it does work. So, yeah, I'm just gonna copy and paste the code that I already wrote in advance, and I'm just gonna change it. So variables in this case would be variables regress. That's what we're gonna change. Oh, hold on. My roommate has been waiting for me to eat lunch the whole time. I'm probably not gonna finish anytime soon, so I'm gonna like let him know that he can just go and have lunch first. It's not Target. this would be finals. Population, film point, some sure regression target on X. Okay, this should work. Oh, no, it does not. Oh, sorry, I'm not analyzing from results.df, I'm using from send.df. Okay, that makes sense. Oh my god, is this gonna create like 8 different graphs? Yes, it is. Oh, perfect. That was quick. Very, very interesting. Okay, this tells me a lot. Alright. I'm gonna go for a quick bathroom break. Give me 2 minutes. Let me tell my roommate to go have lunch on his own first, and then I will explain all of this to you. This is actually very interesting. Okay. Probably need another 20 more minutes. If you can wait, you're not gonna be.
20 minutes?
Yeah. Bro, I've already gone overboard by like 1 hour. I'm not tired right now. It's too long than expected. But it's actually working really well.
Okay. How long you need more?
20 minutes. Then I can go.
20 minutes max.
Yeah.
Maybe I mean I can do my assignments first. Yeah.
Alright guys, I'm back. Okay, so as we can see from all these graphs, right? It's funny because in a linear regression model, the scatter plots of these points are supposed to be linearly like aligned, because it has to be like as directly, the independent variable has to be as directly proportional to the response variable, which in this case is not. Okay. Let's see the first one. PAKE. Wow, this is not even linear. None of this is linear, so this kind of says a lot. PASE, not linear. I mean, okay, this is the linear regression line, the blue line. That's linear regression line, and the plots are supposed to be like closely aligned, which means there is a linear relationship in between the independent, between PASE and like finance population. That's when we use it to create a linear regression model. So in this case, there's no, I don't even know what this pattern is. It's just all like scattered on 0, and then there are like some outliers on top, like what is this? And there's another one that has played a lot of games here. Again, a lot linear. This is sort of, I guess. I don't even know. I don't think it's linear. This is not linear. It's all scattered all over the place. This is not linear at all. We can see that, okay, that's what I was talking about, was a linearity. We can also talk about the homoscedasticity of these plots. So as we can see, champ, okay, this is like a very bad, we probably shouldn't have used champ top 2 and F2, because as we can see from the spread of the x values, like there's only 4, this one's only like 3, and this one's at least okay, alright? But these are like more scattered. These are like better information to use, because like all of them are like unique, you know? Like so many of these are like 1, 0, 1, 2, 3. So from what we can tell, these F2 champ and top 2 probably isn't like the best for a linear regression model, but I mean, none of them are good because none of them are linear. But hey, this is something I discovered which is quite interesting. So linear regression models are probably not the way to go. Um, yeah, so in terms of the homoscedasticity, what it's basically saying is how spread out the value is. It should be like spread out equally among x the x line. In this case, it is not because like as you can see from the first 0.2%, there is no values there. So in terms of the homoscedasticity, that's not really helpful as it should be spread out all across evenly. So that's the only case. The rest of them they're quite even in terms of the homoscedasticity. I don't even know if I'm saying that right. Yeah, this one's interesting. This is very dense over here for the PASC. Um, but yeah, the rest of them I would say is yeah. All right, that's what I wanted to do. Plot them to see the results. I'm going to be adding all the comments onto the code later after I have lunch, but that kind of concludes my analysis. I mean, I guess I could do one more question, but yeah, I'm just gonna do it for the fun of it. Um, my final question. Okay, before I talk about the final question, before I put in my final question, I'll solve my final question. I'm just gonna uh talk about what we solved so far. So the goal of this creating all these linear regression models that you probably never heard of ever was to see how big of an influence some of these factors have when the public picks the picks each team to win a championship. All right. And I thought that the best way is to use a linear regression model, but I also have to account that some of these data may not best fit a linear regression model. Okay, for example, if all the scatter plots were like linearly aligned with this regression line, that would be a perfect fit. Okay, but it's not. It's scattered all over the place. So sometimes if you can see like it's in like a quadratic form, we probably have to like square the values. Then that would give us a more accurate interpretation. So 3 remarks from this. I think that we did a couple of remarks is that I think when it comes to the data wrangling part, like sorting the data, and all that, I think I did quite a good job in that filtering it. The only downside is that we couldn't do a lot with the statistical testing in the sense that in the future, if I have the time, probably outside of this class because statistical testing is not related to this, but I would probably want to create a residual plot to spot like the errors and all. Help me get a better idea uh, of that. On in terms of the errors, that's the first to create a residual plot. The second one is to transform some of the data into like maybe using logging or like squaring because obviously none of these fit a linear regression model well, you know. And lastly, to conduct a multiple regression model for some of these because like for example, realistically, you're not only gonna look at one factor when you're gonna pick a team to win a championship. You're gonna look at multiple. So a multiple regression model allows you to look into several factors, combine them together, and account for whether um to see whether um like that predicts the number of people who pick a team to win a championship. So those are my 3 remarks that I might do in the future when I have time. I'm probably gonna do that for my other class because I also have another project that requires me to do multiple regression models and I am using the same data set, so I'm probably gonna do that then. I'll keep you posted if you guys want. I don't know if you guys want to know about that, but I'll still do it anyways. All right. Yeah, that's like kind of like my 2 cents. I'm probably gonna tidy this data frame as a bit right now after I solve this question. I've really gone overboard by a lot of time, but thank you guys for bearing with me. And so yeah, don't wanna just wanna cut straight to the bullshit. Cut the bullshit. Sorry, get straight to the point. Is there a pattern between increasing number of losses and number of championships? So, yeah, I only want 2 columns, which is the number of losses and the number of championships. Okay, we're gonna be analyzing that for fun. But what I'm trying to say here is that if you have a high number of losses, does that have anything to do with the number of championships? Because you would lose a lot in the championship. You lose a lot in the tournament, but does that mean a high losing rate would mean the a small odd of winning a championship. Let's find out, okay? Because I have no idea. I just kind of cooked that question up, like, out of nowhere. How to get only 2 columns from a data set. Gonna be using Depler again. Oh, basically select the columns. Okay. Okay. One last task, baby. Okay. Okay, I'm gonna use select the columns, the data. Probably gonna use descend.df. That was the latest one that we had. And in terms of that, we want L and we want champ. Okay. And then for that, I want to be doing descending order for losses, so I want like the highest number of losses or lowest number of losses. Selected columns, and I want selected columns arrange one by L and that's it. Okay, I think that's how you do it. Boom. Never mind, that's not how I do it. How did I do it before? Let's see. Oh, okay. That's how you do it. Okay. Copy this here, so for reference, this L. Okay. Looks like I select the column, and as we can see, oh, I probably want to put team name as well. Not bad. Because we can, yeah, select the column. That's no team name. Yeah, I'm just gonna change it to losses and champ. Gonna rename that here. Boom, 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 boom. I also want to have team here. Okay. Alright. So I'm just gonna create a new one here. Boom. Lose champs. Let's just do hit because we don't want to look at too much. Okay. So, you see, this is interesting. So obviously, as true basketball fans would know, Gonzaga has the most losses in tournament history. I think they made almost every tournament in the last like 16 years. They lost 15 of them. So big L. They still made the tournament though, so kudos to that, but they lose a lot. But as we can see, Kansas and Duke have lost 13 and 12, but they managed to win 2 championships each in a span of 7 years. No, 16 years. 18 years. I think 18, yeah. So that just proves that the number of losses, yeah, you may have lost a lot, but this is in a tournament. That means they still managed to reach the tournament almost every single year. So yeah, they may have lost most of the time, but they still won by a couple, 15 and 0, that means for Gonzaga, 15 and 0 means they made every championship for the last 15 years, but they lost every single one of them. 13 and 2 means that they still made for Kansas. 13 and 2 means they all 15 years they made it. They lost 13 of them, but they won 2 of them. Kudos to them. And Duke, apparently one of the years they did not make it because 15 they're supposed to reach 15. There's only a total of 14. Lost 12, but they still won 2 in the last 16 years. I say 16 instead of 15 because we don't count the COVID year. All right. That kind of concludes my analysis. Kind of messy. I tried my best, but this is very interesting, the information that I got. So what I'm going to do quickly here is, you guys don't even have to watch this, but I just want to say thank you guys for sitting all the way to the end, watching this video. I want to say like and subscribe, but I'm probably never going to do this again, if at least not screencast it. I might, but We'll see. We're gonna arrange this. I'm just gonna like tidy this table up if you're wondering what I'm doing right now. Oh, probably gonna write ascending. This. Okay. And then we're also gonna use mutate because I don't think we've used that yet. Oh no, we kind of did up there, but mutate. We're gonna do the R square. This is going to be R squared value multiplied by 100. Okay, I'm probably gonna use stringer one more time to how to convert string to convert percentage. This is something for fun, but okay, yeah, I'm not doing that. I'm not gonna convert it. I'm just gonna multiply it to 100 first, and then I'll just like I already demonstrated how to convert from a string to number. So now for number to string, I'm gonna do it later in the code. I'm too tired right now, but I kind of demonstrated that in the past, so I think that's fine. Boom. Boom. Let's see if it works. Not exactly. Sorry. Sorry, I don't want it to be descending, sorry. I want it to be from the smallest to largest. So, perfect. But alright, that makes sense. This is the final table that we're gonna use. Champ. So yeah, final analysis. The top three that I would probably use, the top three factors that would influence me to pick a team to win it all is probably gonna be champ. The amount of times a team has won the championship, the amount of time a team has gone to the national championship, and I'll just say 3 and 4, which is PSE and PAKE, which are performance against company expectations and performance against seat expectations. This both are computed. Wait, I'm so dead right now. It's computed by some. I don't know how to compute it, honestly. I don't know what algorithm they're using, but yeah. This makes sense. 3% is the lowest variance because top two means the number of times each team has got the top two seed. Top two seed is in the regular tournament. That has nothing to do with the NCAA tournament, which is why it has the lowest variance. That makes sense. And yeah, um, and these all make sense as well because the lower the p-value, the more significant it is. So my top three are Champ, F2, and PSE. Alright, I'm so done. So thank you so much for watching, and peace